Hi friends, good morning. Today let us see some more problems on permutations and combinations. Okay, so let us take this one first problem. In how many ways the letters of the word Sunday can be rearranged? In how many ways the letters of the word Sunday can be rearranged? See, this word Sunday has 6 different letters. N different things can be permuted in n factorial ways, that thing we know. Here we have 6 different letters, and these 6 different letters can be permuted in 6 factorial ways. That is 6 into 5 into 4 into 3 into 2 into 1. That is 6 factorial ways. Absolutely, there is no condition at all. Right? And the same question. In how many ways the letters of the word Sunday can be rearranged such that each permutation, that is each arrangement, should begin with S and end with Y. So we don't want all permutations, we want those permutations that begin with S and end with Y. So let us fix these two places. First place with S and last place with Y. In between we have 4 gaps. So these 4 gaps can be filled in 4 factorial ways, 4 different letters, 4 factorial ways. So this is a second one with a small condition, So let us take the second problem. See, here we have seen all the different letters. If there is repetition, that is, if there are similar things. For example, if you take Saturday, here we have 2 A's, that is 2 similar things. See, if all the n things are different, then the number of ways is n factorial. If there are p things are similar of one kind in the given n things, then the number of permutations is n factorial by p factorial. So n things of which p things are similar, then the number of permutations is n factorial by p factorial. Here we have 8 letters. So 8 factorial by, here we have 2 A's. So by 2 factorial, 8 factorial by 2 factorial is our answer. If there are more similar letters, then see, here is a formula for you, you know it. In n things, if there are p things are similar of one kind and q things are similar of another kind and r things are similar of another kind, then the total number of permutations is given by n factorial by p factorial into q factorial into r factorial, etc. n factorial by p factorial into q factorial into r factorial, etc. So when there is repetition, we have to divide with that. Right, friends? Let us see the third one. In how many ways letters of the word MCOT, in how many ways the letters of the word MCOT or MCET anything, MCOT can be rearranged such that, here the condition is, no 2 vowels should come together. So here in this word MCOT, we have three vowels and three consonants. Here the condition is given for vowels. So now let us arrange the three consonants. Three consonants M, C, T. These three consonants can be arranged in 3 factorial ways. Now we have to arrange the remaining 3 vowels. So the condition is no 2 vowels should come together. So how many places are there for the 3 vowels? How many places are there? So here we have 4 places. Here we have 4 places to arrange these 3 vowels so that no 2 vowels come together. So 4 places are available and we have to arrange 3 letters. So 3 vowels can be arranged in the given 4 places, in the available 4 places in 4p3 ways. So 3 factorial is 6, 4p3 means 4 factorial, 4 factorial means 24, 6 into 24, 144 ways. In 144 ways, we can arrange the letters of the word MCOT under the condition, under the given condition, that is no 2 vowels should come together. Okay friends, let us see one more problem. See in how many ways the letters of the word corporation can be rearranged such that, here the condition is, all the vowels should come together. In the previous problem, no 2 vowels come together. Here the condition is all the vowels should come together. All the vowels should come together. So let us take the vowels 2, 3, 4, 5. 5 vowels are there. 5 vowels are there. In the word corporation, the total number of letters is 11 letters. The total number of letters is 11 letters, of which 5 are vowels. So the remaining 6 are consonants. What are those 6 consonants? C, R, P, R, T, N. These are the remaining 6 consonants. So now in how many ways we can arrange this? All these 5 vowels, let us take all these 5 vowels as one unit, and the remaining 6 consonants in 6 units. Total we have 7 units. So these 7 units can be permuted in 7 factorial ways. These 7 units can be permuted in 7 factorial ways. But here we have similar letters. 2 R's are there. So divide by 2 factorial. So now all the 7 units are arranged in 7 factorial by 2 factorial. Now let us permute the vowels internally. So these 5 vowels can be permuted internally. See here 3 similar letters are there. 3 O's are there. So total number of ways 5 factorial by 3 similar letters are there. 3 factorial. So now the thing is 7 factorial by 2 factorial into vowels. The 5 vowels can be permuted in 5 factorial by 3 O's are there. 3 similar letters are there by 3 factorial. This expression gives the final answer. Right friends? Let us see one more problem. In how many ways the letters of the word detail can be rearranged such that, here the condition is vowels should occupy odd positions or even position. Vowels should occupy odd positions. See, vowels should occupy all positions. See, here there are total 6 positions. 6 positions. And vowels should take the first place, or third place, or fifth place. So vowels should be permitted only in these 3 places. So condition is given for vowels. So now let us arrange the consonants. So T, D, T, L. These 3 consonants can be arranged in 3 factorial ways. And the vowels, 3 vowels are there. 3 different vowels are there, and 3 places are there for these 3 vowels. So 3 vowels can be permuted in the 3 places in 3 factorial ways. So 3 factorial into 3 factorial, 6 into 6, 36 ways. 36 ways. This is your answer, friends. This is your answer. Okay. Let us see, friends, one more problem. If all the letters of the word again, are permuted in all possible ways and arranged in alphabetical order, that is dictionary order, what will be the 49th word? What will be the 49th word? So, if all the letters of the word again are arranged in all possible ways and arrange them and put them in dictionary order, then what will be the 49th word? Let us see. First, let us find the number of permutations, number of arrangements, starting with A. If the first place is A, the remaining 4 letters can be arranged in 4 blanks in 4 factorial ways. 4 factorial ways, that is equal to 24. So starting with A. How many permutations are there? If we put A in the first place, the remaining 4 letters can be arranged in 4 blanks in 4 factorial ways. So the number of words begin with A, 24. Now after A, the next bigger letter in alphabetical order is G. Right, friends? So starting with G. If we take G in the first place, the remaining letters are A, I, N. 4 letters are there, of which 2 similar letters are there, A. So now 4 factorial by 2 A's are there, by 2 factorial, that is equal to 24 by 2, that is equal to 12 A's. Now after G, the next bigger one is I. Starting with I. So let us see the number of words begin with I. If we fix I at the first place, the remaining letters are A, G, A, N, 4 letters, 4 factorial by 2 A's are there, 2 factorial, 24 by 2, that is equal to 12. Now 48 words are over. And the next letter is our answer. What would be the next letter? A over G over I over. So the next bigger letter is N. And alphabetically A, again A, next bigger G, next bigger I. So this is the 49th word. Okay, friends. Thank you. Let us see some more problems in our next session. Thank you. Have a nice day.